This is section 2.1, part B on polynomial functions. Definition here, a polynomial function is any function of the form constant times x to the nth power plus constant times x to the one smaller power all the way down until you get to just a constant. What this format is saying is that you're going to write the highest power first, then the next highest power, and so on until you reach your final constant. We're specifically going to be looking at quadratic functions, which have the form ax squared plus bx plus c, where 2 is the highest power, so this is going to be a polynomial of degree 2. Okay. We will see some polynomial functions, but we are going to be emphasizing in this unit quadratic functions specifically. To begin, we want to fill in the table and graph by hand just the function f of x equals x squared. So that's where x is the independent variable and the y value is equal to x squared. I'm going to start by filling in this table for these x values. And I know that when I square any number, it's going to become positive. Negative 4 times negative 4 is going to be positive 16. Negative 3 squared is positive 9. Negative 2 squared is positive 4. Negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Now I just want to graph each of these values and get the general shape for the graph of a quadratic function. So negative 4, 16, negative 3, 6, 7, 8, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and 4, 16. So when you draw this, make sure that you curve through the center instead of using a straight line like you would use for a linear, oops, I missed on that one, but that you would use for a linear function. You want to make sure that you have a curve, especially at the center right there. This should curve smoothly through the turnaround point. Okay. So the graph of a quadratic function, this shape is called a parabola. If a parabola opens upward, like this one does, then it has a lowest point or minimum. So if it's in this shape, it has a minimum. If a parabola opens downward, it has a highest point or maximum. So a parabola could also have this shape. And regardless of whether it's a minimum or a maximum, that point is called its vertex. So I could label this point right here that is the minimum in this case, the vertex of this parabola. Vertex is a word that encompasses both min and max, depending on what the shape happens to be. Parabolas are symmetric, meaning that you have the same thing on the left and the right-hand side of the vertex. And we call the vertical line that passes through the vertex the axis of symmetry. So just to draw my axis of symmetry in here, the axis of symmetry goes through the vertex, and you can see mirror images on both sides of the axis of symmetry. A point that is 1, 2, 3 spaces away, I'll have a mirror image that is 1, 2, 3 spaces away on the other side. Alright, so we're going to look at the graph of a different parabolic function. This is my graph f of x, and I want to find a few things from this graph. The first thing, I want to find f of negative 2. So remember, in function notation, f of negative 2 inside the parentheses are giving you an x value. So looking at an x value of negative 2, and you want to find out what the y value for that function is going to be. In this case, at negative 2, it seems to have a y value of negative 5. So this is going to be equal to negative 5. F of negative 2 is equal to negative 5. Okay. Let's look at it again. Find f of 3. So f of 3, that one seems to be 0. And part C and D say find x when f of x is equal to negative 5. That's not the x value this time. This time they're giving you the y value, and you need to find the x value. So I would look for a y value of negative 5, and I find one value over here, and I find another value over here. So there are actually going to be two x values that give me a y value of negative 5. One of them was negative 2, like we saw in part A, but the other one that has a y value of negative 5 looks to be x equals 4. So when you plug in an x value, if it's a function, there's only one possible y value. However, in reverse, when you plug in a y value, you may get more than one x. Find x when f of x equals 6. That's a y value again. So I'm looking for a y value that gives me 6, and we're just going to get no solution to this one. There is no y value of 6 on this graph. So no x value could possibly match that value of 6. Now, parts E and F are going to ask for the x and y intercepts. Part E first, the y-intercept. The y-intercept is a place where your graph crosses the y-axis. I'd like to list that as an ordered pair. The y-intercept is the ordered pair, 0, 3. And the x-intercepts, there are also 2 of those. The x-intercepts are going to be the 2 points where your graph crosses the x-axis. So those are going to be the ordered pairs. The x value is -1, the y value is 0. And the other one has an x value of 3, a y value of 0. The last 2 questions for this graph are about the vertex and whether the graph has a maximum or minimum. So the vertex for the graph is the point right at the top of the hill or the bottom of the valley, depending on if it's a max or a min. This one seems to be at the point 1, 4. So the vertex is going to be the ordered pair 1, 4, and in this case, it is a maximum. It's a hill, not a valley, so we've got a maximum. Okay, let's flip our page to the back side. This is going to be a cubic function. Okay, so most of the section we'll be spending on quadratics. We are going to have a little bit of discussion on cubics, especially when you get to the next math class. You take math 139, you're going to do a lot more with cubics. We're going to introduce them here. A cubic function can be put into this form: ax cubed plus bx squared plus cx plus d. So the highest power is 3. It's a polynomial of degree 3. So I want to start by graphing the function g of x equals x cubed. So I've got a list of x values. I just want to plug them in for x, cube them, and get the y values. -3 to the third power, that's 3 negative, so it stays negative. I get 27. -2 to the third power, 3 negative, so I get negative. 2 times 2 is 4 times 2 is 8. -1 to the third power, that's 3 negative, so negative. 1 times 1 times 1 is 1. 0 to the third power, 0 times 0 times 0 is 0. 1 cubed is 1. 1 times 1 times 1 is 1. 2 cubed is 8. 2 times 2 is 4 times 2 is 8. And 3 cubed is 27. Okay, so we're going to graph this. Note your scale on the y-axis. The scale is very small right here. 0, 1, 0, 1, let's see, 0 right here, duh. 1, 2, 3, 4, etc. So it goes every half interval. These little lines right here are every even number, these bigger lines. Okay. So the first ordered pair at -3 is going to have a y value of -27, which is going to put it halfway down there because 28 is all the way down. -2 is going to put it at -8. -1 is going to put it at 1, 0, 0, 1, 1, 2, 8, and 3, 27. All right, so this is the most basic cubic. Now, unlike quadratics, not all cubics look the same exact way. All quadratics are either parabolas that face up or parabolas that face down, but cubics could have several different shapes. That's what this bottom graph shows us, is that there are several different types of cubic. This is the one that we drew, the cubic that starts in the origin, goes up and down on both sides. These are all also other cubics. The one thing that these graphs have in common, the property that all cubics have in common, is that the tails point in the opposite directions. One side is always up and the other side is always down. That is the common point for cubics. So the tails or ends of the graph will point in opposite directions. comparing that to a quadratic, remember that quadratics, or that parabolic shape, where both tails pointed in the same direction, whether it was both up or both down. If it's a cubic, the tails or the ends of the graph will point in opposite directions. Okay, so on the next page, we've got a couple of functions. We're going to look at function notation. We've got f of x and g of x. F of x looks like it's a linear binomial, and g of x looks like it is a quadratic trinomial. So we're going to find each of the following and simplify it. First, f of 4. So we're going to plug 4 into f. So it'll be 3 times x value of 4 minus 4, and we're going to simplify. It gives us, 3 times 4. I could actually do that step. Let me go back and do the multiplication. 3 times 4 is 12, minus 4 is 8. So that would be the simplification for f of 4. For g in part B, we're going to plug 3 in. So that would be 3 squared, x squared, minus x is 3, so minus 5. 3 squared is 9, minus 3 minus 5. 9 minus 3 is 6. Minus 5 is going to give us 1. Okay. In part C, I want to find x such that f of x is equal to 11. So that they want the equation f of x, 3x minus 4, to be equal to 11. I'm going to need to solve that for x. So we're going to start by adding 4 to both sides. That'll give us 3x equals 11 plus 4 is 15. Divide by 3, divide by 3. That gives me x equals 15 divided by 3 is 5. So I found the x value. Part D, g of negative 2. Plug negative 2 in for x in the g function. So negative 2 squared minus negative 2 minus 5. Watch your negatives. When you square a negative number, that's going to become positive. So it'll be negative 2 squared is 2 negatives, making that a positive 4. Double negative here as well. Negative 2 is going to be positive 2 minus 5. So it'll be 6 minus 5 is also 1. The notation in part E, f plus g of x, means add the two functions together. Add the f function to the g function of x, means keep the variable as x. So this is going to be just 3x plus 4, that's f, plus x squared minus x minus 5. When I simplify and combine like terms, I'm going to start with my leading term, which is x squared. Then combine the x's. 3x minus x will be minus 2x. And last, the constant, positive 4 minus 5 will be negative 1. That was f plus g of x. Part F asks me to find f plus g of 2. I already know the f plus g function of x. Now I want to evaluate that function at 2. Remember that this 2 is the x value. So now that I know the function for f plus g, I can use this function and just plug in 2. So I'm going to have 2 squared minus 2 times 2 minus 1. 2 squared is 4, minus 2 times 2 is 4, minus 1, so I'm going to get negative 1. 4 minus 4 is 0, minus 1. If I was just asked to do f plus g of 2, I could have already found f plus g and then I could have plugged it in. So I might have been asked this step and I would have had to know to myself to first find f plus g of x, then plug in the x value of 2. We're going to do something similar in part G and H. We're going to find f minus g of x. Once we found it, we're going to find f minus g of 1. So f was 3x minus 4 minus g. I need to put g in parentheses because when I subtract a function, I need to make sure to distribute the negative. So minus x squared minus x minus 5, and make sure that that negative distributes to each term. So we're going to have 3x minus 4 minus x squared, negative and a negative, so plus x, negative and a negative, so plus 5. So this function would simplify to negative x squared. 3x plus x is 4x. Negative 4 plus 5 is plus 1. That is the function for f minus g of x. So now when I want to find f minus g of 1, we plug 1 into the function. So negative x squared becomes 1 squared plus 4 times 1 plus 1. Keep in mind that this negative is in front of x squared, meaning you do x squared first, then apply the negative. So that negative is not being squared with the x value. It's the negative of x squared. So 1 squared is 1. That's going to stay as a negative 1. Negative of x squared. Then you'll have plus 4 times 1 is 4, plus 1. Negative 1 plus 4 is 3, plus 1 is 4. On the back side of this page, we are going to finish the section. Example 6 here says that the revenue and cost, both in millions of dollars, for Southwest Airlines in T years since 2000 can be modeled by their respective functions. We've got R for revenue and C for cost. First, I want to find an equation for R minus C. Okay. So this is going to be an equation for R minus C of T, and C is a variable. And I find it by subtracting R, the function, minus C, the function. The R function is 183 t squared minus 581t plus 5,964, then minus parentheses, of course, because I want to subtract the entire C function. 102t squared minus 100t plus 4,897. Kind of squished in room there. Okay. Now, make sure since you're subtracting that you distribute the negative through the entire C function. So this will equal 183t squared minus 581t plus 5,964 minus, now, 102t squared minus minus, so plus 100t, negative positive, so minus 4,897. Combine like terms. 183t squared minus 101t squared will leave you with 81t squared. Negative 581t plus 100t will leave you with negative 481t. And for the last two terms, I'm going to grab my calculator to make this computation, but I need to take 5,964 minus 4,897. That's going to leave me with a positive 1,067. So this is supposed to be a function, the equation for R minus C of T. Okay. In part B, find R minus C of 10, and then we want to explain what it means. So I already have the function R minus C. So when I want to evaluate it at 10, I plug 10 in. So I've got 81 times 10 squared minus 481 times 10 plus 1,067. Okay. So 81 times 10 squared minus 481 times 10 plus 1,067 gives me 4,357. And now I need to explain what this means. Always remember that when you explain what something means, you want to explain what you plugged in and what you got out. So this 10, remember, that's the input value, the t value, and that was a reference of years since 2000. So to explain that 10 value, I'm going to say in 2010, 10 years since 2000 is 2010, then I'm going to talk about what happened. So in 2010, revenue minus cost. So if you think about what it means, if you have all the money that you bring in minus all the money that you spend, so if you subtract that result, you should be getting profit. So in 2010, the profit, that's what revenue minus cost means. So the profit for Southwest Airlines was $4,350. 57, the units right there are on millions. So we'll say $1 million. That's the end of this section.